Hello everybody, welcome back, and in this video we're going to be talking about big concepts of partials and overtones as well as fundamental frequencies. So those words may be foreign to you, and if so, that's okay because I'm going to be breaking these down. So basically, to draw it out, when we have a sound, let's just represent it with this sine wave here. It's not just one frequency. So let's say this is 440 hertz. We may be having sounds of, let's say, 880 hertz or 220 hertz or anything really close to that. This makes a sound very complex, which allows us to distinguish between different instruments. That's why a piano doesn't sound like a guitar, and a guitar doesn't sound like a piccolo, which doesn't sound like a cello, which doesn't sound like a violin, which doesn't sound like a trumpet, which doesn't sound like a clarinet, which doesn't sound like thankfully it doesn't sound like clarinet. No, I'm just kidding. Clarinet players are cool too. Doesn't sound like a drum, doesn't sound like I can't think of any other instruments. So yeah, things get very complex. They're not just one frequency. You have multiple frequencies that have something in common that allow us to hear it as one sound. This goes back to the idea of frequency masking. It's hard for our brain to distinguish two sounds that are very similar. So let's say this is twice as fast as this one. This is 440. And this is 880, well, that means this vibrates twice for every time this vibrates once. That's an octave, and octaves sound very similar, and consonants. So yeah, that's the idea of frequency masking. We can't distinguish the difference between different frequencies that have a lot in common. So that's the idea of frequency masking. Now, what's a fundamental frequency? This is the frequency that we name it. It's the main frequency. So just like we said, 440 hertz. This is the fundamental frequency. It may also have an 880 hertz or a 220 hertz. Typically, this is the loudest one, and it is the one we hear. These ones are going to be much more quiet, and we're not going to be able to distinguish them thanks to frequency masking. So that is the fundamental frequency. Now we have these two terms here, which we are going to define. Okay? So, I'm going to do partials in red, overtones in blue. Let's define these. Well, we oftentimes have multiples, or very close multiples, of the fundamental frequency. So let's say the fundamental frequency is 10, just to make things very simple. A partial is anything having to do with the sound, any extra frequency. So, as I said, oftentimes we have multiple frequencies to create the sound. A partial is any frequency that is used to make the entire sound. So let's say we may have a 20, we may have a 40, we may have an 80, we may even have like a 65. Let's go 85. This is a... I just said I was going to do partials in red and I'm writing them in blue. How stupid of me. So partials, we may have them 10, or we may have them in 20, we may have them 40, 80, or even 85. Let me re-erase these blue ones here. An overtone is any above the fundamental frequency, but does not include the fundamental frequency. So a partial is any frequency creating the main sound. An overtone is any frequency except the fundamental frequency. So most often, these will be multiples of the fundamental frequency. So let's say the fundamental frequency is 10. That means this is the first overtone, 20, 40, 80. These are overtones. These are partials, right here. And oftentimes we have names for them: first partial, second partial, third partial, fourth partial, and so forth. So let me make a little graph here. We could have, for partials, we can have the fundamental frequency, 10. this is the first partial. Alright? Now, we have a multiple of that, 20. This is the second partial. This is also the first overtone. 40. This is the third partial, second overtone. 80 would be the fourth partial, third overtone. 160, fifth partial, fourth overtone. So as you can see, there's this pattern where this one is always one lower than this one. So that is a very confusing thing. Many beginner musicians do not comprehend, and then they get confused. Partials include the fundamental frequency. Overtones do not. So you have to remember that distinction. So if you're saying fourth overtone, that's the fifth partial. So that's really all I have to say about partials and overtones. And in the next video, I'm going to be taking this concept, adding a little bit more, and then completing the whole thought process so everything makes sense. And if you want to support me, be sure to subscribe and check out my social links below. Thank you, and I'll see you soon.